Can we have a conversation about nuclear energy? Let me give you a hypothetical. What if it was known by modern science that nuclear energy had zero radiological risk? Now, I know it doesn't. Nuclear does not have zero radiological risk. But let's just have that conversation and see where it takes us. If nuclear had zero radiological risk, then hands down, flat out, it is the most environmentally friendly energy source that we have at our disposal. It requires at least 10 or 15 times less materials than solar or wind. That means 10 or 15 times less mining and milling and manufacturing. That is huge. And then the footprint. It takes about 140 times less land than solar. So what that means is that a lot of solar advocates like to say, you only need to cover France with solar panels to power all of our electricity. Now, I don't really like that idea. They might think that's attractive. But if you look at the amount of land that's required for nuclear, the same amount of energy could be gotten from covering 1/3 of Hawaii with nuclear. So the environmental footprint is just minuscule. It's almost negligible when you look at it in that way. And then the waste, right? 10 or 15 times the amount of materials for solar and wind requires 10 or 15 times the amount of waste that you get from solar and wind. And so that comes back then to this question, well, you made this assumption that nuclear had negligible risk or zero risk. And let's look at that. Is that actually a close approximation to modern science? Well, here's a nice journal paper that goes over this that shows from the science that 3 Mile Island released enough radioactivity to give about 1 millirem dose to every member of the public there in that area. Why is that significant? What's a millirem? Well, just from living and breathing on the earth, from the air we breathe and from cosmic and from terrestrial radiation, you get about a 320 millirem per year just from natural radiation, which means that that's about 1 day's worth of radiation that was released from all of 3 Mile Island to the average member of the public there in that region. And so that is a negligible exposure, That's comparable to a dental x-ray. That's freakishly crazy how harmless 3 Mile Island was. Again, there's the reference. Fukushima, you might say, well, that was huge, right? That's a modern reactor design. And yet the United Nations, it's again referenced in this same paper, the United Nations pointed out that there was not enough radioactivity released in the initial Fukushima release, not the water, which is extremely smaller than the amount that was from the original explosions. All of that radioactivity was not enough to produce any measurable medical effects in the Japanese public. That's huge. That's huge, right? Not enough radioactivity to produce any expected measurable medical effects in the Japanese public. And yet the only people that died were from the panicked evacuation. So fear is what's far more deadly in nuclear energy than is the radiation risk. That's how small the risk is from nuclear, that fear is the biggest killer. When it comes to Chernobyl, that actually did kill a lot of people, right? And yet, referenced in this same journal paper, you can see how the number of suicides from the Chernobyl cleanup workers were higher than any actual measurable cancers. So the biggest measurable medical effect was suicides, fear. This phobia of being exposed to Chernobyl terrified people more than the actual radiogenic effects. And so fear is the biggest killer when it comes to nuclear energy. And fear tends to be the biggest narrative as to why we shouldn't do it. So go figure. What does the science say that we should do to be environmentally friendly, good stewards of the resources that we have at our disposal, and how can we preserve that for future generations? So something to think about. And if you want to talk about waste, it's also addressed there too, where we look at the Waste Isolation Pilot Plant, a licensed geological repository here in the United States in southeast New Mexico. The radioactive materials license is issued by the EPA. The safety basis is regulated by the Department of Energy, and the hazardous materials are regulated by the state of New Mexico. It's been operating since 1999, accepting remote handled and contact handled waste. So the real driver not to use nuclear generally is just going to be fear. That's the common narrative anyway. And right now, yes, we are having a hard time getting them built on budget and on schedule, but we quit building them for decades. It'd be if you quit building cars for decades, are you going to be able to start building them on time and on budget? You might expect that, and that was what was expected of nuclear, but we quit building them for so long, and so we had a hard time there with Vogtle. So something to think about. A lot of stuff there to digest. Nuclear really is the way to go. That would be my argument. But then again, I'm a nuclear engineering professor, and so that's what I know, and so I know the pros and cons of it, and the pros are just so overwhelmingly against the cons. We need to start making it economical, and we need to start being able to build them fast, and that requires investment, that requires commitment. And if we go that way, we end up having the most environmentally friendly and the safest. It's safer than wind. Again, it's in that same paper. Nuclear energy right now is safer than wind. So it's the safest, it's most environmentally friendly. The only thing that's holding us up, in my estimation, is fear. So let's not let fear make our decisions. Let's let science make our decisions. There you go.